We will do our protein project again, but this time with a twist. First, as you can see, I am not manually writing the vector with values, we have no data prepared. We're going to use the randi function to generate our data. So protein intake, randi, minimum, maximum, 128. This will generate a vector with 28 random values, and here we will define our minimum and maximum values. These minimum and maximum values will be between 50 and 65. So 50, 65. And we have 5 tasks. As you can see, I have already written them here. So first, we have to create a variable with the maximum allowed daily protein, ADP for short, allowed daily protein. So ADP equals to 60. 60 is our maximum allowed protein. So we are going to generate values above and below this amount. Next, we have to extract the proteins that are over the maximum allowed value, over the ADP. So occurrences over the ADP. How are we going to do this? Well, we are going to use logical extraction. And we are going to save the extracted values in the occurrences over the ADP. So we're going to take our protein intake vector and we're going to take all of its values that are above, that are over our ADP. So protein intake over the ADP. We are going to leave it like that, and let's run it and see how many values do we have. And as you can see, the values are changing every time. Here we have 6 values, now we have 7, 7, 10, or so 10, and so on. So this is working. We're always getting only the values that are above 60. Now, our next step is to count the amount of days above the ADP. How are we going to do this? Well, we need to count how many elements we have in this new vector. And to do this, we're simply going to take its length. So days over days amount over the ADP will be length of occurrences. And actually, let's leave it like this and let's run it. Alright, so here we have 7 days, 7 days. Again, 9 days, again, 7, 6, 6, 7, 8, and we even get 10 days above our allowed daily protein intake. Now, next step, we have to extract the specific days, the days themselves. So, the days numbers, day 3, day 7, on which we were over the ADP, below the ADP, and exactly on the ADP. This is a way too long for a single row. Let's do it like that. So how are we going to do this? We are going to use the find function. As you probably remember, the find function is giving you the index on which the element that you care about is located. So it's not going to give you the value, it's going to give you the index. So days over the ADP will be find protein intake more than ADP. Let's run it. So we get 4 days over the ADP with the new generated vector, and these are the 13th day, the 19th, 20th, and 27th day. So as you can see, these days are also changing. These indexes correspond to these values in our protein intake vector. So we get 8 days, these are the values, and these are the specific days on which we had this protein that was over our allowed intake. So let's see below the ADP. So days less than ADP, find protein intake ADP, and let's also get the ones that are exactly on the ADP because it's the same thing, we just have to change the condition. So protein intake equals ADP. Now let's run it, and as you can see, very interesting. On the first day we were exactly on our allowed daily intake, and this is the only day on which we had exactly 60 proteins intake. Then we have a lot of days that are below the allowed intake, and we have 6 days over the intake. So let's run it again. Now we have 2 days on the ADP, 3 days, 2 days. Now it's harder to get values that are matching our protein intake because we're comparing only against a single value. So, and the values below 60 are more than the values above 60 because our limits are from 50 to 65. So we have from 50 to 59 for the less intake and from 61 to 65. So we have a lot less values for the over the ADP. That's why for the over the ADP we get a lot less values than from the less. Now, finally, we can check which days are more and which days are less, the ones on which we had less or more than the ADP. So we can check less or more than ADP, and what we have to do is simply check the length of these days. So we can say length days over the ADP less than length of days less than the ADP, and if we run it, we get a true result. Let's try again. So we get only true. There we have it, a false result. Now in this case, we have more days that are over the ADP. So we have 14 days over the ADP and 13 days less than the ADP. Now it's, as I mentioned, we are generating very few values above our limit. That's why we are going to mostly get a true result that the days that were less than the ADP were more than the other days. And if you want to be on the edge, we can modify this a bit and we can say, let's comment it. So we can say less or more than ADP, and we are going to concatenate. So we're going to say length of the days over the ADP along with the days on the ADP. So we're going to count the days that were on the 60 to be on the more side, and we are comparing again with days less than ADP. Now we should get the false result more often, but there we have it. So it's not that often anyway, so we still get a lot more values for the less than the intake. Now this is how you can perform very simple tasks that on the surface may look a bit complex, but really are not. Now let's quickly document our code and end the project. So here we have initial data, randomly generated data. Here we are extracting amount and occurrences of above, below, low, and on the ADP. So here we have extracting days above ADP and counting them. Here we have extracting the specific days of above, below, and on the ADP. And here we're checking which days are more. There we have it. A pretty simple project, nothing too complex. We don't have 50, 100 rows of code, but the idea was to practice generating random data, extracting values, indexes, and as you can see, indexes by themselves are not always just indexes. In this case, the indexes corresponded to days. So let's move on. And there we have it.